So here we have the third question on vectors. Now we all are familiar with the triangle law of addition of vectors. Suppose we have two vectors A and B. This is vector A. This side is represented in magnitude and direction by vector B. Then as per triangle law, sum of these two vectors, the third side which is joining the tail of the first vector with the head of the second or the final vector, so gives us the addition of these two vectors. Now in mathematics we have an inequality known as triangle inequality. According to which sum of two sides of a triangle in magnitude, sides, when I'm saying side, it's the length of two sides of a triangle, is always greater than or equal to the third side. Now we wish to apply the same property here in triangles in case of vectors. Now when we have to say length of a side, this is a vector which is representing this side. If I have to represent the magnitude of this vector or the length of this side, I need to write it is magnitude or modulus of vector A, which is exactly this length. Likewise, if I wish to represent this length, I have to write magnitude of this vector B, and I have to write the length of this vector or this side. Basically, I have to write magnitude of vector A plus vector B. It is representing this length, the third side, as you can see in this triangle. It is this length. So magnitudes, they are scalars or constants. Now, as per the triangle inequality, sum of two sides of a triangle is always greater than or equal to the third side. So this is what we are going to prove in case of vectors. Sum of two sides in terms of magnitude, sum of two sides means vector A plus vector B. Sum of two sides of a triangle is always greater than or equal to the third side. That means the length of the third side, means it is magnitude of vector A plus vector B. So what we wish to prove is magnitude of A vector plus magnitude of B vector is greater than or equal to magnitude of vector A plus vector B. So here, remember, whenever we are dealing with vectors and we come across modulus, starting with square of modulus is very, very important here. So if we look for the solution here, we start with vector A plus vector B, its whole square. It's magnitude of vector A plus vector B whole square. What exactly are we going to draw from it, or what help do we get by writing so? We all are aware of the property that if we have a vector x, its dot product with itself is same as magnitude of vector x whole square. Now we are going to make use of the reverse that of this property. That means magnitude of vector x square can be written as dot product of vector x with itself. So in place of x vector we have vector A plus vector B. So square of the magnitude is the dot product of vector with itself. Vector in this case is vector A plus vector B. Now this time it's a dot product of vector A plus vector B with itself. That means vector A plus vector B. Now let us expand it. It is A dot A plus A dot B plus B dot A plus B dot B. This is the expansion. Now using x dot x is mod of x square in terms of vectors. For vector A dot vector A, I can write magnitude of vector A whole square. I can write the same for B dot B as well. Vector B dot vector B makes it magnitude of vector B whole square. So A dot B and B dot A, they are equal since dot product is commutative. So this is basically 2 times of vector A dot vector B. We can expand it further. We can write vector A magnitude square. Now if I open it, we have 2 times of, what is the expansion of dot product of two vectors? It is the magnitude of first vector into magnitude of second vector into cosine of angle between them. If you assume that theta is the angle between A vector and B vector, then it is cos theta, and this is magnitude of vector B whole square. So magnitude of vector A plus vector B whole square comes out as magnitude of A square plus magnitude of B square, vector B square, plus 2 times of magnitude of vector A, magnitude of vector B. Now pay attention. Here we have cos theta. We start with this cos theta. Cos theta has a maximum value of 1. That means I can write cos theta is less than or equal to 1. With this cos theta, we have 2 mod A mod B attached. So we wish to introduce this entire term here. So with cos theta, we have 2 mod A mod B. 2 is positive, mod A is positive, mod B is positive. So if I multiply this inequality by 2 mod A mod B, nothing is going to change. And the sign in between is going to be the same. It is 2 times of magnitude of A, magnitude of B cos theta, and this is less than equal to 2 times of magnitude of A, magnitude of B. We arrive at this portion. This portion. What else do we have? We have magnitude A square plus magnitude of B square. So we add magnitude of A square here and magnitude of B square on the left hand side, and we do the same thing on the right hand side also. So if we now look at the right hand side, this is like magnitude of vector A square plus magnitude of vector B square plus 2 times of magnitude of vector and magnitude of vector B. If you watch it carefully, this is something like A square plus B square plus 2AB. This is basically the expansion of magnitude of vector A plus magnitude of vector B whole square. This entire is expansion of magnitude of A vector plus magnitude of B vector whole square. And this left hand side, what exactly is this? This is exactly what we have written here, and this is nothing but its square of the magnitude of vector A plus vector B. So in place of this, which is exactly this, we can write the left hand side very conveniently. It is vector A plus vector B whole magnitude whole square. Now taking the positive square root here, since we are dealing with the magnitudes, taking the positive square roots here, we get vector A plus vector B is less than equal to magnitude of vector A plus magnitude of vector B here. So sum of lengths of 2 sides of a triangle is always greater than or equal to the length of the third side of the same triangle. And this is known as triangle inequality. We call it triangle inequality. Why do you call it triangle? Why are you using the word triangle here? Because we are dealing with triangle. Inequality, because this is the sign of inequality. Less than equal to, greater than or greater than equal to, they all represent the inequalities or inequation signs. So this was one of the most important questions of this chapter. So over to the 4th question now.